Oh, good morning, third hour chemistry. Welcome to Friday class. I realize I'm not here today, but we're going to do a little bit something different. Yesterday, first off, you guys should have already turned in your backyard observation yesterday, and you guys should be not at this point organizing your folder. Yes, you guys should have already passed your papers back, but no, you guys should not be organizing your folder. It is time to learn. Um, our one task today is to go over what we did yesterday and kind of build on it. Now, our task is, in the end, to learn how to complete ionic and net ionic equations. Now, for some of you who would like to learn from something different, I'm going to show a YouTube video of somebody instructing you how to do this and go over it, so maybe you guys would learn a little bit better. So, let's go to this video.
About net ionic equations, which is actually an extension of double equilibrium reaction. So let's go into detail on what exactly is happening when you have a double equilibrium reaction. Okay, so double equilibrium reaction is when two ionic compounds come together and switch partners, right? So typically what you have is it's in an aqueous solution, meaning that these compounds are in water and making solutions. So let's take, for example, we have sodium hydroxide. When you put it in water, it actually breaks up into its ions. We have a sodium ion and a hydroxide ion. The same thing happens with all ionic compounds, but let's reiterate that with copper 2 chloride. Put that in a solution, or in water to make a solution, and we have one copper ion, one copper plus 2, and 2 chloride ions in the beaker. Okay, great. What does that mean now? All right, so let's say we added to these two beakers together. See what would happen.
So at this point, we've just reiterated that we've got sodium hydroxide, NaOH. That's what it looks like in the solution. Down here in the overall reaction, we have NaOH plus CuCl2. This is a double replacement, so nothing new at this point.
Well, most of the time, you're going to have a precipitate. And a precipitate is a solid form or solid pieces within that solution. So some sort of solid will actually happen. You probably have a solubility chart that your teacher might have given you that tells you what actually makes a precipitate.
AKA the purple sheet that says soluble or insoluble.
A simpler way of writing precipitate instead of having to write the whole word is PPT. So you might see that actually in the future too. So this actually means precipitate. These words are pretty important also. Within this reaction, this is going to still be aqueous, and this is going to be our actual precipitate. This is going to be our solid that's going to actually be formed. So we're going to say NaCl, the product, is soluble, meaning it is dissolvable in the solution. It will break up into its ions. It will still be in solution. This is going to be insoluble, meaning that it's going to be the precipitate, meaning it's going to be the solid of this reaction. This is actually going to stay together. So let's write this out more accurately to describe exactly what is happening. So we look at the complete ionic reaction. We're going to break this up.
All she's gonna do right now, everybody, is she's gonna do the exact same thing we did yesterday. She's gonna take the aqueous reactions and undo them to write them in ionic form. So to break them up to see which ones are positive, which ones are negatives.
We don't like it together because we know that they separate in solution, as we've mentioned earlier. So instead of writing NaOH, I'm going to write Na plus and OH minus. Okay? Then I'm going to break this up into its ions also because it's broken up. It's an aqueous solution. So we're going to say it's Cu plus 2 chloride ions. This 2 comes out. We have 2 of these guys, 2 chloride ions. It's going to produce salt, which we said is soluble. It's in an aqueous solution. It's going to be broken up into its ions, Na plus Cl minus. And this is a solid, so it stays together. We're going to say it's CuOH2. Now, I actually forgot to balance the original equation, so we're going to have to go back and make sure this is balanced so we can do it properly. Okay, so there's 2 chloride. Let's go back up here. There's 2 chlorines. There needs to be 2 chlorines here, which means I have 2 sodiums there, 2 hydroxides. This is balanced. This will also change our our complete ionic equation. We'll have to put a 2 here. We have 2 of these guys, both of them. This 2 will tell me I have 2 of these and 2 of these. Okay, so now it's balanced. This is helpful. Okay, so now we have this long equation. This is actually a much more accurate description of what is actually happening in the reaction. Then we go into something called spectator ions. When you think of the word spectator, you might think of like a basketball game. When you watch a basketball game, you're a spectator of that basketball game, right? If you go to like a Wizards game, you would be a spectator at that Wizards game. You wouldn't actually be involved in that Wizards game. You're not affecting the outcome of that Wizards game. You're actually just there watching the event happen.
And this is what we talked about yesterday. There are people that are going to be doing stuff during this game or this reaction, and people who aren't.
That's what these spectator ions are the exact same way. Okay, they're just watching the reaction take place. They're just spectators. They don't really do anything. They don't affect the outcome of the actual reaction. So what do I mean by that? What's a spectator ion? Okay, well, there are ions on both sides of the reaction. They haven't changed. So for example,
So for this, yesterday when we talked about playing a game, the matching game, that's what she's doing right now. She's figuring out which compounds or ions are the same from the left to right. So we're just seeing if we can match them. If we match them, they're spectators, and we don't want them because they really not are really not doing anything. So at this point, all she's doing is we're playing that memory game or that matching game we did yesterday. If they match, they're gone.
we have a sodium ion here and a sodium ion here. That's a spectator. We can actually cross that guy out. He is not doing anything in this reaction. Then we have hydroxide ion. We don't have one over here, so we can't. That's not a spectator. We have copper over here. We don't have copper over here, so that's not a spectator. We have 2 chloride ions, and yet we have 2 chloride ions here. That guy's the same on both sides. He's a spectator. He's just watching the event happen. He's not important. So then
So once again, all she's done, and she's found the ions that are similar on both sides, not similar, but exact copies. She's eliminated to 2 NAs on both sides. She's eliminated to 2 Cl minuses on both sides.
we have our leftovers, and that's what we get to our net ionic equation, our net ionic reaction. So let me just bring those down, and I'm going to say 2OH minus plus Cu plus 2 gives me CuOH2. And we're going to make sure this is our solid. This is our net ionic reaction. This is what actually is happening within this reaction. So let's take this and go up and do this in one.
So that's it. That's our task. Our task is to go from, as up here, this overall reaction, the ones that we've been working on for the last couple weeks or a couple days, to breaking it up into their ions as we did yesterday, which the only thing is we're taking them, breaking them apart. And once we break them apart, we eliminate the ones that are exact copies to figure out who's doing the work in the reaction. At this point, she's going to do another example, and I would like you guys to follow along and write what she's writing down. So I'll give you guys, so whoever's doing this, please pause it until everybody's ready. Thank you. All right, so everybody should have a piece of paper out, and we should be ready to go.
More time.
And for those people who are really confused right now, go with it. Don't be stressed out, please. So don't stress out. Just go with it. I'll rehash it on Monday, but I want you guys to have a good idea when I get back on Monday. So key 1, don't stress out. Just let it go.
Make sure that we understand. Okay. An aqueous solution of aluminum chloride and sodium hydroxide react to form solid aluminum hydroxide. All right, let's break this up into its overall reaction. So we have aluminum chloride. We know this is Al plus 3 and Cl, and this is a minus. So when they actually make their compound, it's going to be Al, Cl3, and we know it's aqueous solution, so we're going to write AQ. Okay. Reacts with sodium hydroxide. We have sodium, which we know is Na. This is plus. Hydroxide is OH minus. So together they're just going to be NaOH. And this is an aqueous solution also. React to form a solid, and this tells us what our precipitate is, aluminum hydroxide. So we know aluminum hydroxide is going to come together. This is Al plus 3 OH and a minus, so it's going to be Al OH3. And then we have another product. So we did the outside ones, we're going to do the inside ones. Na and Cl is left over, so we can just say NaCl. And this is our aqueous. This is soluble. Okay, so let's balance this equation, make sure it's balanced correctly. We have 1 aluminum, 3 chlorines. Let's make 3 chlorines here. That means 3 sodiums. Let's do 3 sodiums on this side, making it 3 hydroxides. 3 hydroxides, good, great, it's balanced.
So at this point, if you haven't caught up, please catch up. You guys should have on your top line OR, which is overall reaction or original reaction. You should have your AlCl3 aqueous plus 3 sodium hydroxide aqueous yields aluminum hydroxide plus 3 NaCl or 3 sodium chlorides, which is aqueous. So don't go on until everybody has this. Once you guys have it, please go on so we can try to find out the next reaction, which is the complete ionic reaction.
All right, so let's do our complete ionic reaction. We have to break it down. Don't forget, aqueous solutions need to be broken down into its ions. Let's do that. We have Al plus 3 Cl minus ions plus 3 Na plus ions plus 3 OH minus ions yields, this is our solid, we're going to keep this together, AlOH3, and then this is aqueous, so we're going to break that up. Okay, so now we have to find our spectators again. So which ones are our spectators, meaning they're the same on both sides? Well, I have 3 NAs over.
So once again, like she says, she's just eliminating the ones that are identical on each side.
Here, and 3 NAs over here, cross those guys out. 3 chlorides here, 3 chlorides here, cross those guys out. Now we're left over, this is our net ionic equation, ta-da, we're done. Al plus 3 OH minus yields AlOH3. This is our solid, so precipitate. It's completely balanced, we're looking good, awesome. The one type of double.
So that's all we have, ladies and gentlemen, for net ionic equations. We've gone through there. We've written the original equation. We've broken it up to see what is being ionic and what's not being ionic, as in what's staying a solid. And finally, eliminating spectators to figure out what is our overall net ionic reaction. You guys have no homework this weekend, so don't worry, but I want you guys to have a head start on this when I come back on Monday. So on Monday, we are going to go over how to do this step by step, just like she did. So hopefully you guys have an overall gist of it, and we'll finish it up later. So have a great weekend, and good luck to the sports teams this weekend.